Educational Communications and this station present Environmental Directions with Nancy Pearlman. On this series, we explore the effects of human influence on the Earth's ecosystems and discuss solutions to environmental problems which affect the quality of life on this planet. Environmental Directions gives you the kind of information you need to help you participate in decisions impacting your community, the nation, and the world. Now, here's your host, Nancy Pearlman.
Hello. We are going to be talking about the use of geodesic domes for climate resilient and affordable housing with my guest, Morgan Bierschenk. He is co-founder and CEO of GeoShip. Formerly, he was Chief Technical Officer with Ceramic Cement Corporation and also was an information activist with the Iceland Modern Media Initiative and has held various positions with Intel. Welcome. It's a pleasure to have you with us.
Hi, Nancy. Thanks so much for having me.
Your company has a very innovative approach to trying to solve the need of affordable housing, the need for climate resilient housing, through the use of geodesic domes and unique materials to build those. But how do you describe a geodesic dome? Because when I look at your website and the pictures, they're beautiful structures. Round, circular. Why is a geodesic dome different than an ordinary dome?
The geodesic dome is recognized by the American Architectural Association as the lightest, strongest, most efficient means of enclosing space known to man. And it makes sense because it's a triangulated sphere, right? And a triangle is the strongest shape, and the sphere minimizes surface area. You have just a very strong, efficient structure.
How big can they be? Because an ordinary home, we want a kitchen, a living room, bedrooms, play areas, offices now. Can you have that in a geodesic dome, and can you divide the space inside of it?
Yeah, absolutely. Most geodesic homes will be 2 or 3 domes connected together, and the square footage can range from, as little as 300 square feet all the way up to 4,000 square feet. I mean, you can connect like 4 domes together potentially and have little domes off the side that are maybe a little more separate space or connected by longer hallways. And the bigger domes can be divided as well inside, because usually you'll have a loft in the dome or like a second story that is maybe takes up half the square footage of the first story, so you can put full dividing walls down below.
Architecturally, domes have existed for thousands of years. We see them quite often in traditional palaces, cathedrals, churches, and other structures, but they are just part of those buildings. The rest of the buildings are more rectangular or square. You're talking about a dome without the other rectangular structures, correct?
Yeah, correct.
The concept of geodesic domes seems to have been introduced by Buckminster Fuller many decades ago. Why was it so innovative then and innovative now?
The geometry actually goes way back. Plato defined the geodesic sphere originally. He called it a container for becoming, or a Gaia, essentially. All of the Platonic solids kind of nest within its lines. And you even go farther back, and sort of the flower of life geometry that we see throughout many ancient civilizations, that is the geodesic. The geodesic dome is the flower of life in 3D. I think it's very unusual to invent a new geometry and the math required to construct that geometry, and that's really what Buckminster Fuller did in the 50s and 60s. He said back then, they're like wooden spaceships. It's like, this is the ultimate geometry, but we don't have the material science yet to manufacture them. And that's what we're doing with GeoShip. We're using a completely new material science that was developed at U.S. National Labs in the early 2000s and is now really revolutionizing quite a few different industries. So we're bringing that bioceramic or chemically bonded ceramic material science together with the geodesic dome and together with injection molding technology. So really, home building, I'd say, comes down to 3 things: geometry, materials, and method of manufacture. And when you approach home building from kind of physics, first principles, what is the most efficient shape, what is the most efficient material, and what is the most efficient method of manufacture, that's where we're really excited about the ceramic geodesic dome, really optimizing at all 3 of those levels.
You mentioned injection molding. Explain how that is done. And you said new materials, including something you call biocement or biocrete. What is that? Is that ceramic material like we see in pottery?
It is technically a ceramic. It's highly crystalline with covalent and ionic bonding, but it is like a cement in that it doesn't require high heat. It fires at room temperature very quickly. Within minutes, you can heat up through an exothermic reaction and you can take the part out of the mold very quickly. And it is literally a bioceramic. It's actually used in the human body for bone repair. The chemical composition is very similar to bone. It's like phosphate, magnesium, calcium, potassium. So these bioceramic domes are building very close to the chemical structure of bone, and they can be extremely high strength, like nearing the flexural strength of steel, because we extrude carbon fibers and cellulose fibers through the ceramic material to give you a really high-strength ceramic composite.
Are there toxics in this material? And where is the material obtained? And is it done ecologically and sustainably? Because we know that we don't want to be cutting down our ancient forests for wood structures. We know that we don't want to have factories building steel and other structural materials that are polluting. How good is this material in terms of helping and protect the environment?
We reduce the carbon footprint of housing by about 93%. So the embodied carbon footprint is made up of embodied carbon, operational carbon, and recurrent carbon. In the building materials, the energy is reduced by around 90% compared to a conventional wood house. And we're designing for a design life of 500 years. So there's no shingles to replace, there's no paint. You can resurface and repair the dome with the same material that it's made from. And the operational energy, the amount that it costs to heat and cool the dome, is extremely low because we have 10-inch thick insulation cavities, a really tight envelope, the reduced surface area of the dome. This is one of the reasons we're so excited about it, is that it's 100% non-toxic materials. So there's no petrochemicals. It's not like an epoxy or some other type of material in there. There's no metal, there's no wood, there's no concrete, there's no plastic. Like the frame, the exterior, and the interior are all these bioceramic natural fiber composites.
You're based in Nevada City, California, between Reno, Nevada, Sacramento, California. Is that where you get the material? You don't mine this, do you?
It can be mined, and it can also be a waste stream from many different processes. Like, for instance, a main waste stream from wastewater treatment plants is the phosphate that we need. A primary waste stream from seawater desalination plants is the magnesium oxide and the potassium that we need. And interestingly, for every ton of lithium ion they mine, they produce 10 tons of magnesium oxide with a boron element that makes it waste for every application except these ceramics. It's like perfect. So as EV battery mining operations ramp up, the waste streams from that can be used for ceramic domes.
I see new housing all the time in the city. I'm in Los Angeles. They tear down old good buildings and put up new structures, but I don't see them putting up geodesic domes. I go out and see new suburbs. I don't see the geodesic domes. I know that you are encouraging intentional communities or villages of geodesic domes, but can they also be individually? And I know that while you're based in California, you're working with 60 other countries. Where do we see these structures?
Yeah, I think to date, geodesic domes have always been really challenging to build with conventional materials. It's hard to get them to not leak, and there's a lot of waste that's generated when you have to basically create all these triangular panels out of plywood and drywall and kind of conventional rectilinear building materials. So the material innovation really opens up geodesic domes that are more affordable and healthy and sustainable and resilient, kind of all in one. It's interesting that actually 100%, as far as I know, of every housing cluster, so like housing development or neighborhood in the U.S., is rectilinear structures. And I mean, the round structure goes back. Humans were living in round structures even before square structures. There's a really fundamental longing, I think, that a lot of people feel to like have an option. Some people want to live in a box and some people want to live in a bubble. And, those are kind of the two fundamental options. And I think we're really opening up that round living space for the first time. As affordable housing crunch comes, combined with needing more to reduce our carbon footprint, combined with more resilience to fires and floods and hurricanes and earthquakes, the ceramic geodesic dome is, I think, a really important housing technology for the future.
Well, I live in a rectangular structure built in the 30s in Los Angeles. I was fortunate enough to inherit a cabin in the mountains designed by a mid-century modern architect, John Lautner, and it's his first roundhouse. And it's wonderful living in a roundhouse. You feel like you're in the forest when you're inside. So I can definitely attest to the beauty and advantages of roundhouse living.
Mm-hmm. We're really productizing it for the first time, being able to develop a roundhouse product that can be manufactured very efficiently in automated factories and easy to assemble on site. There's no cutting or measuring, and it's like the owner builder can build it to reduce their costs, or they hire a contractor that can put it together pretty quickly.
Your company has announced something that you call Earthshot Mission. You have a goal of 1 million homes. What is your goal's deadline for that?
Yeah, so just to clarify, our Earthshot is, first of all, to make the best home on Earth the most affordable one, and then to scale manufacturing to 1 million domes per year by 2036.
Is this all done through individual investments? Do people or companies hire your company as the architect, or how does this work, and where do they go to get more information to be involved?
The construction industry in general is being really, for lack of a better word, disrupted in the last 5 years. The companies, GeoShip and a handful of other companies, are really emerging with 3D printing technology and factory home building technology. And that's just like any other startup. Basically, we're raising capital from venture capitalists as well as everyday investors, because I think one of the things that differentiates us is that GeoShip will evolve into a multi-stakeholder cooperative governed by a perpetual purpose trust. So that means customers and nature will own 50% of the company, 30 to 50%, and will be governed by a trust. So the board of directors are basically trustees that have a legal responsibility to execute the mission of the company, and the mission is really to build villages, regenerative villages that help people reconnect with the natural world. And people can find out more about GeoShip on our website. If you just Google GeoShip, GeoShip, the website will come up and you can learn more there. We're really building a community of future customers and investors to really delve in and go on this kind of ride with us to transform the housing industry.
Or they type in www.geoship.is.
Mm-hmm.
You mentioned pre-orders. How long does it take if somebody wants a geodesic dome? And are the materials shipped? Do you help build it, or do they have to find a local person to take those materials and your designs and actually make the structure?
We are just starting pilot production. So once we start volume production, people will be able to order the dome, and it will arrive in a shipping container, essentially, about 30 days later. And we can send out kind of certified contractors to install it for them, or they can participate in the installation themselves.
Is there an intentional community existing now with geodesic domes that one can visit?
Not permanent geodesic domes. There's a lot of little communities out there with more temporary structures.
So all those beautiful pictures are computer designs that I see on your website?
The village pictures are computer designed, and then the real image is the dome that we installed here in Nevada City as a prototype.
Can one visit the prototype?
Potentially, yeah. We're limiting that a little bit because we just don't have the bandwidth to walk people through, but we will be walking groups through at different times, and you can schedule that through our website.
The geodesic dome started here in the United States, but other countries are utilizing it. What other architects and construction companies are using it most extensively, in what other countries?
France, Italy, Australia, New Zealand. I wouldn't say it's being used extensively by architects as much as people ask their architect to build it. I can't really say that how much is proliferated through other countries. I think maybe that the 60 stat is that we have pre-orders from 60 different countries for the dome, so a lot of interest internationally.
It's wonderful to hear about new innovative technologies to try and help solve some of our critical housing problems. I'd like to thank you so very much for sharing with us what you are doing in this arena, and thank you for being my guest.
Okay, thank you, Nancy.
I have been speaking with Morgan Bierschenk, who is the co-founder and CEO of GeoShip. I'm Nancy Perlman. Thank you very much for joining us, and do tune in again next week.
If you would like free information about these environmental issues, go to www.ecoprojects.org or call 310-559-9160. Environmental Directions with your host, Nancy Perlman, is a community affairs program of the nonprofit organization Educational Communications and this station.